Hey guys, today we're going to look at adding and subtracting algebraic fractions with denominators that are not monomials, but some of them will involve binomials or trinomials. If we look at example 1, you'll notice that there's a plus 3. You have a binomial. It helps to sometimes put the parentheses there to remind yourself that those go together. You want to find the least common denominator, which is the least common multiple, and you do that by multiplying these two. So if you think about what you would do with regular fractions, if you had like 1/2 plus 2/3, your common denominator will be 6, right? Because 2 times 3 is 6. So here you do the same thing, you multiply them, but you don't really multiply them. You just write them next to each other being multiplied. You don't actually distribute through. If you remember, everything with algebraic fractions has to be in what's called factored form. So we leave this in factored form and we figure out what you would have to multiply each fraction by to get to this common denominator. So I look at my first fraction and I say this one would have to be multiplied, the numerator would have to be multiplied by 5. And my second fraction, my numerator would have to be multiplied by a plus 3. So what I'm going to do is I'm going to write this all in one big fraction instead of two separate fractions to save time. So instead of having to copy this over twice, I just put it into one fraction. It would be 9 times 5 plus 2a times a plus 3. Now your numerator is going to have some multiplication and some addition. What you have to do is you have to, in the numerator only, you have to distribute and then combine like terms, or that means add or subtract. Okay, your denominator you don't distribute. That's in factored form. There's no addition or subtraction. But because we have addition or subtraction here, you have to distribute here and then to be able to add and combine like terms. So my numerator is now going to be 45 plus 2a squared plus 6a all over 5 times a plus 3. And then I'm going to reorder it in standard form, 2a squared plus 6a plus 45 all over 5 times a plus 3. You look to see if possibly something can be factored. The numerator can't be factored, so you leave it. I'm going to go to example 2. Same idea. You have a denominator of m minus 6 and a denominator of 7. So your LCD, your least common denominator, will be 7 times m minus 6. So I'm going to set up one big fraction, 7 times m minus 6. The first fraction would have, the numerator would have to get multiplied by 7. And the second fraction, the numerator would have to be multiplied by m minus 6. So I'm going to set up 7m plus m times m minus 6 in my numerator. Again, all this has to be combined, and in order to do that, you have to distribute here and then add or subtract in other situations. So I'm going to distribute. I get 7m plus m squared minus 6m all over the denominator, 7 times m minus 6. These can be combined. I have m plus m squared all over 7 times m minus 6. You notice that there's a GCF here. I can factor this. So this is going to become, in factored form, and actually this should have been reorganized to be in standard form, m squared plus m. So it'd be m times m plus 1 over 7 times m minus 6. And this is my final answer in factored form. That means that it's all multiplication. There's no addition anymore. Like up here there was addition. That's why I had to distribute. I'm not distributing here. I'm just leaving it for the person to see that nothing else can be simplified. There are no common factors. Okay? In example 3, if both of your denominators are binomials, you just do the same thing. You have the product of them would be the least common denominator. So your least common denominator here would be the product of these two binomials. It would be c plus 2 times c minus 3. Okay, so I'm going to set up one big fraction with c plus 2 times c minus 3. And I go to the first fraction and I say, okay, this has to be multiplied by c minus 3, the numerator, and this numerator has to get multiplied by c plus 2. So I set that all up in my numerator, 5 times c minus 3 plus 6 times c minus 2. And again, I have to here distribute in order to then be able to add these. So in my numerator, I have 5c minus 15 plus 6c minus 12 all over my common denominator, c plus 2 times c minus 3. And then I can simplify. 5c plus 6c is 11c. Negative 15 and negative 12 is negative 27. So I have as my final answer c plus 2, c minus 3 is my common denominator, and my numerator is 11c minus 27. There is no GCF here in this numerator, so I leave it like that. Okay, if it had a GCF, I would factor it. Moving on to example 4. Same idea, and you can pause me and see if you can do it on your own. My common denominator would be the product of these two binomials, so my least common denominator would be 2a plus 1 times a plus 2. So I set it up as one big fraction, 2a plus 1 times a plus 2. My first numerator would have to be multiplied by a plus 2. My second numerator by 2a plus 1. So in my numerator, I have 3a times a plus 2. Now be careful, this is minus, so it's minus 2 is going to distribute to 2a plus 1. So I'm going to combine, again, distribute, so that you could then subtract. I have 3a squared plus 6a minus 4a minus 2, all over my common denominator, 2a plus 1 times a plus 2. And then I'm going to simplify. 3a squared plus 2a minus 2, all over 2a plus 1 times a plus 2. If your numerator can be factored, which usually if it's a trinomial like this, it can't be factored. But if you can, you do. Okay, now they're going to get a little bit harder, where if you look at your denominators, if you look at example 7, oh, there's a typo here. Scroll down. Just ignore this example 5. That's not supposed to be there. In example 7, if you look at your denominators, you don't want to just multiply them, because if you notice, there's a GCF here. So you have to factor this first before you could find the common denominator. The GCF is 3. 3 goes into both of those terms, so it'd be 3 times m minus 4. Now you look at the denominators and you say, what's my least common denominator? My least common denominator is, well, this has m minus 4 and this has m minus 4. And then one of them is being multiplied by 3. So the least common denominator would be 3 times m minus 4. It's what they would both go into. So my first fraction has to be multiplied, the numerator has to be multiplied by, it's missing, the denominator is missing the 3, so times 3. My second fraction has the whole denominator, so it just gets multiplied by 1. So my new fraction with the common denominator of 3 times m minus 4, my numerator is 3 times 3 plus 1, or 1 times 1. So it would just be 10 over 3 times m minus 4. Again, if you could simplify, you do. Example 6, another one, you'll notice that I can factor my denominator. I can factor this x squared minus 4 into x plus 2 times x minus 2. That's difference of squares. So as I evaluate my least common denominator, they both have an x minus 2, but this one also has, the first one has an x plus 2. So my least common denominator is going to be x plus 2 times x minus 2. It would be the denominator that they would both go into, the least common multiple. So my fraction is now going to be set up over x plus 2 times x minus 2. The first fraction doesn't need to be multiplied by anything except for 1, because it has all parts of the denominator. The second fraction needs to be multiplied by x plus 2, because that's what it's missing in the denominator. So I have 5x minus 3 times x plus 2. Remember, the minus 3 is going to distribute in, so you have 5x minus 3x minus 6 all over x plus 2 times x minus 2, which then becomes 2x minus 6 over x plus 2 times x minus 2, which then I notice that my numerator has a GCF of 2 times x minus 3 over x plus 2 times x minus 2. Now I'm done. I can't cross cancel anything. That's my final answer. Okay. And we'll do one more for today and we'll stop here. And then I'll do the rest of the examples in tomorrow's lesson. So in this one, I noticed that I have a GCF of 3 here that can be pulled out. So 3 times m minus 4. And when I look at my denominators, they both have n minus 4, but this one has 3. Let me just see something right here. Oh, that is the same thing. I was just checking. It looks familiar. Yeah, please ignore example 7. It's just a repeat. Okay, let's go to example 8. Example 8, I have a GCF in both of my fractions now. So my first fraction simplifies into 3 times x minus 5. And my second denominator is 5 times x minus 5. Notice that they both have x minus 5, right? So my least common denominator is going to be x minus 5. But now this one has a 3 and this one has a 5. As they're monomials, what number do 3 and 5 both go into? It would be 15. So that's going to be your denominator, your least common denominator. The first fraction, the numerator, has to get multiplied by 3 times 5 to get to 15, and it already has the x minus 5. And the second fraction has to be multiplied by 3, because 5 times 3 to get to 15, and it already has the x minus 5. So in your numerator, you have 25 plus 6, which is going to give us 31. So 31 over 15 times x minus 5. And this can't be simplified. Okay. We're going to look at the next two. We'll look at those tomorrow, just to kind of break it up a little bit for you guys. Okay? Thanks. Bye.